You're here today to see root cause analysis. Lee, take it away.
All right, thank you, Robin. Appreciate it. Good morning, good afternoon, good evening. I will go ahead and go off camera here so you can see the whole screen. So root cause analysis, what's the most effective method? I think this is a great topic. I'm honored to kind of share with you some of my thoughts and experiences. And my bio, a little bit about me. Spent a few years in maintenance reliability. Thought I knew enough to write a book. So if you get it, hopefully you learn something. But here today to kind of look at root cause analysis. So I want to start out. I got a couple polls. I want to kind of get an idea from the audience, where you're at with your program. So poll question number 1, Robin. Are we able to share the poll, Robin? Can you still hear me?
I can, and the poll was shared. I just closed it, Lee. In your go-to webinar menu under polls, you'll see that 57% of the audience said yes, and 43% of the audience said no.
Oh, okay. Good mixture then. All right, second poll then, for those of you who have a program, how many have you performed? Or not nominally on an annual basis, just some kind of an estimate. I put some kind of ballpark ranges on the screen.
All right, and Lee, if you'd like me to verbalize them again, I can.
Please.
We have 37% that said 1 to 9, 26% that said 10 to 49, 20% that said 0, 14% 50 to 100, and 4% were greater than 100.
Okay, that's a good normal distribution. All righty. So these are the things I plan on covering, kind of talk about, well, what is root cause analysis? Why is it worth doing? How do you decide when to do it? And then some processes that I developed that help quite a bit with the different methods. Some of the methods, I'm sure there's maybe a few more that I didn't choose, and then some examples. So I want to start first with definitions, because I think root cause analysis is kind of a buzzword. It's really important continuous improvement process, but people say, oh yeah, we did a root cause analysis, and all they did is they changed out a bearing. So a failure analysis is, yep, okay, the bearing broke, I went out and changed it, the component, and we're good to go, and that's like all there is to it. That is really just a failure analysis, and that probably happens, well, hopefully it doesn't happen a lot in your plants, but it's probably more common than going through the full-blown RCA process. And then there's kind of intermediate called the root cause failure analysis, which really kind of talks about the mechanical or electrical part of the problem. You do get down to all the root causes and really do an evaluation, but it's not quite as comprehensive as a full root cause analysis. So root cause analysis really, it says takes out the word failure, but it kind of looks at, well, do we need to do training? Do we need to do something with our processes? Do we need some new tools? All those other kinds of things that you should look at to really kind of help, prevent the incident from happening again. So with that, I actually want to do one more poll, just kind of get a flavor for the folks. I understand 40-some% of you don't do any. But I think this is kind of a good way to characterize, where people are at, with RCAs.
And I'm going to give the poll about 15 more seconds because there's a little more to read on this one.
Sure. Okay, I will say as we go through this, I actually have like 80 slides. There's a lot. Normally, when I've done these webinars, I have about 4 or 5 of them and I talk to them. And so the main purpose I did this is because I think there's a lot of really good information on the procedures and policies and some tools that would be helpful. And that's why I had asked, Robin to have that handout. So there's a lot of wording in there, a lot of more definitions and methods and things like that. So I won't spend a lot of time on some of the slides because they're very wordy. Kind of hit the highlights, which is really what this is all about. So Robin?
All right, and so our results are 39% said the results are mixed depending on who is responsible. 27% said the results add a lot of value that improves our processes. 17% said our company doesn't perform any. And then our last two tied at 9%. Both we would like to experience the value, but very few are conducted, and they seem to be more of an exercise with no value added.
Okay, great. So 3/4 or 2/3 really think adds a lot of value and whatnot. So that's good to hear. All right, so we'll launch into it. So here's some of the benefits. A lot of them are pretty obvious. Improves your liability. Hopefully it reduces, repeat offenders and continue to have problems and reduce cost, from not having, failures. There are a few more benefits. Kind of part of the process is evaluating your reliability program and maybe what more you should be doing or things you're not doing. Training, of course. Maybe there's some gaps in your training that you find out that, hey, I'm putting this bearing on, but they're beating it on. We don't have the right tool. If we're really putting it on properly. Things like that. And getting the company and your team all educated, is another key thing. So I see the goals as, it's got to be across the company. It can't be like HR has their process, production has their process, maintenance has their process. There should be one process, for the whole company. And they should use the same database so you can look across, what other folks are doing. And executives can too. It's a one-stop shop, is a good thing. But, tracking the value, like what do we get out of it? There are some software programs that give you the opportunity to estimate the savings or what was the cost of this? Was it production? Did I have to buy a bunch of materials or parts? My labor was involved, things like that. And for some, industries and companies, they may have to, share with their customer, what happened, which sometimes can be a little unnerving. So I want to kind of talk about, who owns the process? So, is it production? Is it maintenance? When I came to the company I'm in data centers, I've been with it almost 7 years. And my boss says, well, why are you involved in root cause analysis? I'm like, well, a lot of companies use reliability people to do this because that's where the failures are, and so she decided that I wasn't really the best place for it to sit, honestly. And so our engineering department, has the task now. So, as long as they get done, that's really the important part. How do you pick what software? Do you need a software? I mean, without software, it's like not having a CMMS. It's kind of difficult to track them. Software really helps you track like the action plans and outstanding actions and things like that. And of course, it's always good to have a written policy and procedure. So I made up this flow chart. It's always good. Kind of let people know, okay, these are the steps. Okay, yeah, we're going to do an RCA. This is how we get ready for it. This is how we execute it. This is a follow-up. having something like that is very useful. Looking at software, there's a lot of them out there. So this is actually the list that I'd come up with. Some of it I just did searches on, the internet and who does what. And then across the right side of it, I'm like, okay, well, for an RCA, these are the elements that I want to be able to do and capture in the software. I'm gonna have a summary table. I want to have all the causal factors. What are the recommendations? I want to be able to track it. Now you can set this up maybe just in SharePoint and make a table. I mean, you can just use a spreadsheet, if you want to. So it really depends on what the appetite is for the company, who all is going to use it, how many people, how robust you want your program to be. But software does really help a lot, and we'll get into a few more where it really kind of helps guide the process a lot, makes it a little bit easier. So establish the program. All these things here are part of what I'd kind of set up, what expectations for all the team members, of course, a guide for the software. I have to create a RACI, for the process, who's responsible for what, and then kind of looked at the risk and impact and effort. I got some follow-up slides for these areas. So here's what I came up with, team member expectations. It's always good to kind of level set with the group as you get started. Everybody's professional, listen to others and all those, good kind of ground rules. Non-conformance codes, I think, are very useful. I think it kind of probably helps with the training aspect for people to understand what are the different components that could be part, of all these cause and effects possibilities. And so in our procedure, I listed a section, I just displayed one for measurement, but, we have one for each one of these topics to kind of help people. And they kind of line themselves with the fishbone that we'll get to later. And creating a RACI, who's responsible for what and accountable and whatnot. It's a really good thing with any type of organizing a team, whether it's, an event team, like in this case, or your department. Risk assessment table. So I don't know how many people think of the risk, with RCAs, but, part of deciding if you need to do one, what was the risk to your business? What was the risk to keeping that customer because that machine was down for 2 days and they couldn't, get their product? And of course, I'm sure everyone has done like a criticality analysis on their equipment, which ones are more critical, and the more critical are, I'm sure that's a higher risk of losing that piece of equipment. So it should be kind of a factor, if it's kind of an auxiliary piece of equipment, then maybe your RCA doesn't need to be as robust. You maybe use spend less time on it, and use the appropriate level, that you think is necessary. And this kind of helps with that. Now, I have a table of potential solutions. As you come out of it, there should be a pretty good list of what the possible solutions could be. And then out of that, you can evaluate it and get management permission for which ones you're going to do. And then, of course, assigning it, an impact effort ranking really kind of helps, drive the priority of what they should be set at. And then you can plot them on the next slide on the table and kind of get an idea, where they fit, and kind of concentrate on upper right, where you're going to get the most bang for the buck. So triggers is a really important thing to define. Like, when am I going to do, these? So I got 2 slides here that I've used as triggers. We have some kind of injury, hopefully not lost time, but it could even be, maybe a first aid case. It wasn't really significant, but it's a significant near miss of a kind. You got all these environmental permits and things, and, maybe OSHA came in and did an inspection and found some problems. Of course, haven't really any kind of a fire, even if it's just a kind of a lot of smoke, coming out of a conveyor, or some product caught on fire or anything like that. And of course, critical equipment. And a couple other ones, did impact the customer. Maybe have, an SLA or some type of an agreement. Maybe it's really expensive, $100,000, and or maybe something just seems to happen, like every week, or even maybe on a monthly basis. Maybe you find something in your meantime between failure analysis that says, yeah, okay, we got a chronic problem here, this type of a pump or something, and that could be a trigger for it. If you don't document these triggers, then how do they get initiated? And I can be honest, in my company, when we first started the program, I had all this process, everything laid out, had training and whatnot. And the premise was that, our directors at the director level would say, oh, yeah, okay, we had a big enough problem here. We need to do a root cause analysis. Now, I'll be honest, we went a whole year and nobody ever said we need to do one. So that's not very useful. And we have done some, but it's kind of been at least a little bit slower than I want, not quite as robust as I want. But I think that this process will hopefully help you guys maybe do a little bit better job than what I've been able to do. So initially, you got to assign somebody. Make sure you get all the data. That's really important. You get the right people. It probably needs to be a cross-functional team. People maybe were involved there on site when it happened, or at least people have a lot of knowledge of it. Decide what elements you want to do, and these are what I'm calling the elements. We need to have meetings. It could be virtual. I mean, it could be across the company. It could be, say, a chronic problem. You have that machine in 3 different states. And you need to get those people involved, or it could be in person. Either way, and make sure you identify the problem properly. Not just like broken bearing, but kind of be descriptive, of what really happened, and then look at all the, the cause and effects, relationships and whatnot. Then throughout, develop what corrective action you're looking at, countermeasures, making sure you keep the database up to date. And one of the key things I think is communication. It isn't just within the people who did it, but it's within the departments that were affected, department or departments, and then maybe across the company. Maybe there's a company-wide communication, and to highlight the importance of the program, you can say, hey, we saved this much money, we solved this problem, we helped the customer with this. All those things can be big wins and help, more buy-in, across the company and everybody. And then, of course, document in some type of final report, which with a predefined format of all the elements that you want to make sure that are included in it. So some success things that I believe are, the key is getting the right people involved, having a good kickoff meeting. The people are trained, they're engaged, they're not there just because somebody told them they got to be there. Of course, you can use, leadership skills to kind of get them engaged. And they have a deadline. If you don't have a deadline, and a month can go by, 2 months could go by, because everybody's busy, right? Everybody's got a day job. So you have to have some kind of a goal date to shoot for. If management isn't on board with it, then you might as well not waste your time, and update the database and make sure you got an appropriate due date. So here's where we start with a lot of the wordings, the procedure. That as you go through the procedure, the goal is to uncover problems and the root causes and all the symptoms, latent causes, human causes, all the things that you can. And depending upon the type of problem, there could be more weighted, to certain areas, whether it's a human, it's a machine, and whatnot. So you have to kind of make sure your procedure covers, the different types of problems that you're experiencing. Whoops. Okay, I'm sorry, I went the wrong way. So some root cause attributes, you want to have good solutions. You want to properly identify all the problems, and often there is definitely more than one root cause. And you don't want to just stop at one. A part of continuous improvement is finding as many potential problems as there are. And of course, you need to prioritize them. Like, yeah, this is a program we're looking at, doing next year or later in the year. And maybe you need to escalate it, maybe start a little bit quicker. Or maybe it's a program nobody thought of, to kind of close a gap. And why do they fail? I already mentioned one, it really weren't effectively, initiated. because somebody has to make the cost. Somebody has in charge has to say, yep, okay, we're going to do one, and then you start the process. So you want to have good facilitators. If you go with a software program, they usually have really good training. I did like 3 days of training with a bunch of our engineers and operations folks when I started the program. We actually picked real situations, real problems, and solved them, after they went through, teaching the software and those kinds of things. And you don't want to not let, you don't want to just take anybody's idea and just, that's really not a problem. You want to take all ideas, you want to document them all, put them all out there, and everybody discuss them and just prioritize them. Just emphasize that there are no dumb ideas and we need to consider them all because, we don't know what the right answer is yet, And a couple other things, you're not having the right people involved, not enough resources. And another good thing about a database is if the database is shared across the company, then you can go in, anybody can go into it and look and say, well, does somebody else have a problem on this? And hopefully it's a sortable database. They can look at like equipment or like issues, maybe it's something with a building elevator. So let me go look up RCAs with elevators and be able to find other things. And sometimes that can be really useful. And it could be more of a preventative thing, look for problems people have on same exact kind of equipment, and you can be proactive and try to head them off before they happen to you. So failure analysis, as I defined before, when you should do it, it's kind of an isolated thing. It's pretty obvious what the cause is. Everybody is kind of a good consensus on that is what it is, and that's really all that's necessary. Now, do our CFA, root cause failure analysis, ask yourself these questions. Could there be some gaps in our training or our maintenance practices, or maybe our parts inventory, that we didn't have? And of course, it depends on the management and what kind of level, they would agree that you should shoot for. And for RCA, hopefully you're using the triggers and, look at all the different triggers I kind of shared with earlier and, yeah, potential impact to clients and whatnot. So a couple other things. Yeah, if it's mechanical, electrical, but it still could be a training issue. It could be inventory, all those other kinds of things. Maybe it's there's a problem with a part. You have a problem with a bearing burnelling on it. Maybe it seems to be a lack of lubrication, but it caught on fire, burned up all the grease. So it's really kind of hard to tell. Is alignment problem. Maybe you have good vibration, data on it. Maybe you've done alignments, maybe you haven't. But to come up with a root cause, you may need to send it out. And sometimes whatever equipment is, maybe you need to send it to a third party and maybe not the manufacturer. Sometimes the manufacturer could skew the information a little bit. So just something, your OEMs and manufacturers, and a pretty good idea for that. And the software is always handy. And even if it's just a fire analysis, maybe you still want to document those. Have a separate category so those can be searched in a database. So let's talk about methods. You should look at the complexity of it. Does the software lend it to itself? Make sure people are trained on all the different methods, at least, particularly the one you're going to use, but probably other methods. So it'd be kind of maybe a team decision to make sure you're using the appropriate level. So we start out with 5 whys. I think everybody probably is familiar with those. You just keep asking why till you get to the bottom of it. So, every problem does have some kind of a cause, and you want to kind of really get to the root causes, not just do a high level, and be persistent. And can you drill down any further? Maybe you have 6 whys, 7 whys, who knows? But you stop, when you think you get to the bottom of it. So 5 whys is pretty useful. It's very common, and it's one of the simplest tools and whatnot, and something I think a lot of people use. Here's kind of a simple example. A lot of you may have already seen this. Why did the belt stop? Well, the pulley stopped turning. Why is the pulley not turning? Well, it's not getting power from the motor. And why not? Because the motor stopped working. So what happened to the motor? Well, it burned up. Why did it burn up? It was overloaded. And then for some reason they didn't know the load rating, or they overloaded whatever the motor was working with, those kinds of things. So, there could be, maybe you need to post signs, maybe you need to, adjust your procedures and policies and things like that, or maybe it's a training issue, or maybe somebody, came to work in a bad mood, and overloaded it, or, who knows, there could be a lot of different reasons, but kind of get you down, okay, well, this is the real problem, and, what do we do about it? So this is the fishbone. You've probably seen this, so it kind of looks like, a fish, and you got all these main categories, to look at. Is it a people problem? Some with environment, sometimes they say is an act of God, is a tornado or hurricane or something came in, is a problem of materials, which could be something that, the manufacturers, sometimes you'll find that they just really didn't use the highest quality of a material. I can say one of the machines I had has a lift table on it, and the chain just kept breaking. After they broke about 3 times, I'm like, okay, this is crazy. So I put on a double chain, then the double chain broke. And then I tried a higher, steel for the member that had the sprockets on that was driving the chains, and that broke. And I brought in the manufacturer. The guy came in and he actually admitted to me. He says, well, when we were designing this machine, the stacking part of it was kind of the last section of it, and we just didn't really spend as much money on it as we should have. So it wasn't really the greatest design to begin with, and I ended up getting a scissors lift, getting rid of the whole chains and just use that for the discharge. So you can run into things like that. So fishbone kind of uses a cause and effect. It's very structured and really kind of helps you drill down, just like the 5 whys, and kind of look at all different possibilities and whatnot. And some, general stuff like all of them, everybody, the team needs to agree on the problem statement, make sure it's covers all the elements that they think should be discussed. It may not just be just the fact that, the shaft broke or something was out of line. There may be more to it than that, that somebody may have knowledge of that you don't want to forget about and make sure you discuss. And of course, brainstorm as much as you can. Keep asking why does it happen, and use the 5 why part too. So here's a fault tree analysis. This is another tool, and this tool is used more as a kind of a proactive approach, more for safety engineering and reliability engineering. And you kind of look at, okay, what are the undesired states? Like maybe stop working, is a little bit too generic, but, maybe the fuel valve, we're not getting fuel to the engine or something like that. And then you kind of break that down. And what are all the possible symptoms and causes of, problem with not having fuel and whatnot? Honestly, this isn't one that I've used, but I just want to share that. It is an option, and there could be some times that it might be useful for you. I kind of look at it with like an FMEA, which probably most of you are pretty familiar with, more of a proactive approach. You look at, say, a solenoid valve, how can it fail? It loses power, it sticks, it's not lubricated, all those kinds of things that go into like FMEA types of things. This is kind of like that, more of a proactive RCA, if you will. But I think there's a use for it, and at least understanding that it could be a tool, could be useful for certain problems, particularly if they're bigger problems. And just here's some symbols that they use in that analysis. So it is kind of a deductive process. It started at a single point, as you can see in the earlier slide. You got different types of faults. I'm not going to go into a whole lot of details on it. And you kind of use the different symbols to kind of help. gauge, I guess, where the problems are and where you should focus on. Okay, and the process, so you identify what is, you break it down from the top level, and make sure you got the right data and stuff like anything else. Now, another one that you may not be that familiar with is sort of a similar one called the current reality tree. So they actually have these things called UDEs, the undesirable effects, and you start with a list of problems. So it's not like, oh, well, I experienced, this bearing break or shaft break, something like that. It's almost kind of the same theme, sort of, as an FMEA. What are these effects that could be there? Like, okay, my engine won't start. Well, it's an alternator. There's all these different things, not getting fuel, spark plugs, wires, all that stuff. What are all the things that kind of go into that? So this is a different methodology that kind of helps steer you towards solving a problem in that light. So you kind of come up with these UDEs and things that need to change going through it. How are they linked together? How are they related? That may have an impact on what kind of solutions you come up with. And here's some details about how do you actually execute through it. And there are some cause and effect implications for it. And sometimes, the symptoms come up and whatnot, of course, like, most of this root cause analysis. So another one I never really had thought of much before until I started designing a program was a Pareto chart. I never really considered that as part of root cause analysis. More of you're tracking, like maybe how many overdue PMs you have and things like that. And this might be a tool you could use. They're pretty effective. Kind of talks about, what are the main causes, how many causes could we have to this problem, or have we had, which one's the biggest one? It's kind of like when you run your mean time to failure and come up with the bad actors, right? Well, it's not just the bad actors that rear their ugly head the most, but it's the ones that cost the most and the biggest impact on the business. And it is easy format. People understand them. They see them a lot. And then there's a whole lot of stuff in here, and I'm not going to go through it all. And make sure you pick the right axes. And is it a week long? Getting all the data, look at the scale, drawing it. Is it percentages? Is it sums, averages, all that kind of stuff. So you do all those things, and you come up with what are results. What is the training that we should be going, that we should have, which is key. What is my policy procedure? I've kind of gone, actually, a lot of this presentation are all the elements of my policy procedure that I generated for my company. The more of that you have, the more everybody understands expectations, the more that the team will know to follow it and not skip things. Part of it, like I mentioned earlier, is the report. What elements, do you want in a report? Obviously want to list the team members, what was the original problem, what are all the root causes, maybe some analysis of why some are more significant than others, which solutions are you going to take on board, who's going to do them when, and have some way to track that to make sure it's an effective program. Now, sometimes if it's a personnel issue, it may end up getting kind of thrown with, HR, and it may not be something that you can really highlight too much. Just kind of depends on your company and its policies. So here's some examples. So in the data center industry, we have a lot of uninterruptible power supplies. Here's one we had a bunch of fuses blowing, and then as we researched it more, we found we just weren't calibrating. This voltage regulator, really weren't looking at it. It wasn't in our PM plans, and unfortunately, we weren't lubricating our circuit breakers either. So those are the two main things that we came out of that. So that was a useful RCA. Then we had another one with, we lost the utility power on one of our main 16,000 amp breakers, you know, to our site. And it was a CPAM relay out in the substation. And some engineer decided or picked a setting, hey, we need to lower the arc flash rating, and created a problem. So he came up with some things about going checking other relay settings to make sure they're in, and kind of certainly during at least a 5-year arc flash survey, check those out and make sure they're set where they should be and they're staying there. Another thing in data centers, we provide electricity to servers, and a big thing is redundancy. So all the servers have at least 2 power feeds. And so if you're gonna do maintenance and you open the breaker, you wanna make sure you open the right one. And we did not in this case. And as I went through this, there's a lot of different things, like as I list here, marking the breakers. We had a procedure. There are a lot of steps. Some steps were marked NA that shouldn't have been. Some of them were kind of sloppy. They didn't have the guy's initials. They didn't put a date in it like they should. There's a column for it. They had this internal process. It was like the only site in the company had all these colored stickers, and it really wasn't well defined. In a procedure, though people sort of knew, what they were supposed to mean. And the risk level as they went into the job just wasn't really what it was, or, the actual risk. And so there just wasn't much emphasis on it and things like that. So when you go through the proper software and the proper steps, it really kind of helps uncover some of these other things rather than just saying, hey, somebody made a mistake, and we need to discipline them or what have you. This one, it kind of took one of our generators out of business. And we had the vendor do the root cause analysis. And they did a lot of analysis on the crimping part when the ends of the cables, crimped on the lugs. And they had showed some pictures on the type of crimping. And you can see the cross section. And there's probably, golly, I don't know, it's like maybe 8-10% of air, where there weren't wires in the cross section of it. And so they came up with a different way to crimp it. Which is kind of interesting. I hadn't really seen, that type of a solution for something like that. But this is in one of our UPSs. We had some problems with some capacitors actually sort of like exploded. They caught on fire. You made it, shut a bunch of stuff off, and of course you never want to have any kind of a fire. Well, it turned out, the manufacturer found out the supplier of that particular type of capacitor had issues, and they had gone back to the vendor, and the vendor wasn't really responsive. They weren't really helping solve the problem. And there's only just a small percentage of their market where they use these specific capacitors, probably maybe 15% of these types of UPSs. So it wasn't widespread. And they've come up with a way that as the capacitor kind of bulges and it hits this little switch and it turns the system off with just one way, and as an interim until they actually go in and replace the bank of the capacitors with a different manufacturer. So a lot, some of these can definitely, you need to work with vendors. Some of them can be internal, but again, you make sure you get the right people involved. Now this was an expensive one. We had a new building, got new generators, like 3,000 kilowatt generator, 3 megawatts, and it didn't have a lot of runtime. It was almost testing, and it blew a cylinder out, and they took it over to France, where it had been made, and found that they just didn't have the clamping force, on the counterweight bolts. So this is a very expensive one for them. Okay, and takeaways. I like to say that I think RCA is really a value-added process, and from a reliability point of view, it really makes you maybe dig a little bit deeper in all the possible causes and what do you have the tasks that do this? Now, One company I was in, every time we had an incident, oh, we need a PM for that. We need PM for that. And I'm going through all these PMs. I'm like, gee whiz, it's a one-time event. It never happened again. I got one PM to do like one task. It was just kind of a knee-jerk reaction. I would recommend kind of steering away from that mentality and looking at the real root cause and what is a value-added thing. Because there are some failures and events that could be considered sort of a one-off. And I know, lots of management, they want to see action. What did we do for it? Oh yeah, we did this, and so we're going to prevent it from ever happening again. Which is really kind of pie in the sky. So it's just something you have to really kind of look at and defining your process, so you're looking at the right things. And you got to do the follow-up action. You got to track it. You got to hold people accountable. Whether it's a report that goes out to department heads, say these are outstanding ones, these are ones that are overdue. Make them part of your plant's KPIs. Different things like that. Whatever works the best. Just to make sure it gets addressed. And of course, some of the actions, maybe end up being a little bit more involved than you thought when you first made it up, and that needs to be factored in to to your plan. And when you look at that impact matrix, and the cause, that can kind of help you refine, the level and maybe the number of people. It may not just be a one-person job, to kind of help put that to bed. So that's mostly what I was going to share today. I hope this was worthwhile, and I'll come back on camera. One other thing I wanted to mention as I come back on camera was I personally like to do a lot of reading, and I found a really good book that I like to share with you. And when I developed my program, not only did I use the software vendor, and I shared with them my policy procedure to get input, particularly on the portion that was using the software. Found this really good book. So you can find it, I imagine it's on Amazon, put out by Reliability Web, called Root Cause Analysis, Driving Bottom Line Improvements. And it's short, it's only 50 pages, but it kind of simplifies, setting up a process. And you may have heard of Ricky Smith. He's got his own consulting business called World Class Maintenance. Pretty good guy. He does a lot of stuff like preparing people for CMRP and different things. And it's also written with a lady called Susan Lobel. So it's pretty easy reading, a lot of pictures, so you don't have to read everything. Everybody likes pictures. It's a pretty good book. I recommend it if you want, even if you have a program, like from the handout and from this book, there might be some good tips and tools in there that you would benefit from. So Robin, do we have any questions?
We do, Lee. Thank you for another great presentation. Audience, if you have burning questions for Lee, now's the time to get them in. Lee, let's go ahead and get started with the questions that have come in so far. The first question I have is, who should really own the RCA process?
Yeah, that's the key thing, and it's not going to be the same, I don't think, for every company. I already shared a little bit about mine. I owned it. Then the decision was made, well, Fitz and Tech Ops. And later on, I said, well, I'd still be happy to do it. But they're like, well, if you're going to end up just asking us to do it for you, there's a lot of internal politics, you have to deal with. Probably the best department would be, I would think, would be a continuous improvement department if it exists, or the quality folks. Somebody that's got the training on it. When I looked at, who should get trained, there's oftentimes there's, people on the floor, really good operators who want to better themselves, good supervisors want to become managers. It could be a good professional development thing to get other folks involved in the process and learn it. And maybe if you get, significant weight of those folks, maybe that'd be the best department. I don't know if safety would be the best one because they're going to be focused on, OSHA first aid cases and near misses and lost time accidents and things like that. So, I think reliability is a good place for it. It's very similar to FMEAs. and those type of proactive approaches. So it really depends on, what the management thinks, and then who's actually going to get it done, and is it sustainable.
All right, thank you. We have plenty of questions, so we'll try to get through as many as we can. The next is, when performing RCA, Lee, do we need to consider assumptions, or should we stick just to the facts of the incident that's happened?
Yeah, that's a good question. Well, of course you want to use the facts. I would say whatever the assumptions could be, when you're early on, you don't know if they really are an assumption or not. I mean, you may not have all the facts associated with a possible assumption, but I would document them and probably assign a team member to go do some exploratory surgery and investigation and get more background on it, and either prove the assumption or unprove it and figure out if it should be more considered. That's the way I approach it. I wouldn't just put it off to the side and ignore it, but I really think you'll get a much better product if you overturn all those rocks that are out there.
Good point. Which method of RCA do you consider the best and most appropriate?
I really like the cause and effect. I think the 5 whys is good and does that to a certain level, but there's some companies that have some really good software out there. I went to training with 2 of them, and I just happened to be SoLogic was one of the trainings that I had on that software spreadsheet, and I think it was Allied Reliability, or I forget the name off the top of my head. But they both, they use the yellow stickies, in the training, and you come up popular root causes. But you put it all and you build this tree, in the software, and like the instance where we opened the wrong breaker, it'd be like, well, so why was the breaker unopened? And it's like, okay, I need the breaker to be shut for things to be powered. And you kind of create all these branches, and each one of them goes down to a root cause. And I think that's a pretty comprehensive approach of doing it. So my personal belief is I think that type of software is the most effective. And I know there's some out there, like you may get emails from a company called Think Reliability. I think they're very good. I get emails from them every week, and they just use Excel, and and it's free, actually. So if you want to use something like that, at least maybe to start the program, maybe a better way to invest. But I can tell you, like the software that I've been talking about with SoLogic, whoever, is really not that expensive. And they have, an enterprise version, individual versions, so you can make those kinds of decisions on who all needs to use it.
All right, next question. And there's some clarification on this question too. The question is, do you treat safety RCA differently than hardware RCA? And then in parentheses, they have some clarification, using different analysis teams, different software and such.
Well, I can say that my company does. Our safety environmental folks, they have their own process. And a couple of months ago, I had a few meetings with them and some other departments in the company, because the executive want one database that they can go look at. They don't have to look in 2 different places. So I think there's probably value to kind of having a separate, not maybe a total separate process, but a hybrid process that kind of covers all the elements of safety and environmental things, just because of the different requirements and things. I think logically you're still looking for cause and effect, but with regulations and things like that, there's probably a lot more that comes into play, and maybe even with community environments, affecting folks outside the building and whatnot. I can see kind of splitting them to a degree. It's the best I can come up with.
Okay, we'll try to get us through as many of these questions as we can. Everyone, thank you for your patience. There are lots of questions. The next one I have, Lee, is how is reality charting software for doing RCA?
Well, that's a good question because, it kind of looks at what are the undesirable effects. And so let's say you had a problem where, the example I gave, the motor was overloaded. I think you could probably start with calling that, the undesirable effect, like, the motor stopped turning. And that could be the starting point. Then you could kind of build out your tree to what are all the possible causes. Maybe it's armature shorted. Maybe the bearings, one of the bearings seized. Maybe there's alignment between a rotor and stator. Maybe the leads, are coming loose. There's all kinds of, obviously, and it could be something, maybe one of the phases, from the power company, just single phased or something. There's all those different things. It could be a way to, I guess, start, the process. I honestly don't know if I would use it as an RCA for all the different, like all the ones that I brought up there. I really think it's more of a proactive approach and look at the design or, people, well, what could happen? I mean, it is advertised as for safety engineering. So it may fit more, with safety type of incidents and whatnot. So you probably really just have to look at the problem and then kind of read up on it, educate yourself, understand it more if that'd be a viable, venture.
All right, nextly, all right. What are some of the KPIs that we can generate from an RCA?
Yeah, well, one might be like how many? I know like one company I was in, they wanted an RCA, or well, RCFA per plant, one per month. And I can tell you, when people have that and that gets published, by golly, they're going to get that one RCA or RCFA. And it may not, the quality of it may not be there. It may not be necessarily so worthwhile. Where, I just read an article last week from a training company that does a lot of training in RCAs, and they kind of recommend like 2 RCAs per facilitator, is a good goal. So, that might be something to shoot for, if you're the person in charge of continuous improvement of, how many you want to track. I think how many actions come out of it, tracking the completions versus the due dates. And then, of course, if you can come up with a value, I think that'd be great. Like how much did we save? How much did it cost? Those types of things. Those are the ones that come to the mind right away. You don't want to get too many of them. And I know SMRP has a really great list of KPIs, and I honestly did not look at that recently to come up with which ones that they might already recommend. Might be another source.
The next question may be a little polarizing. After an RCA, should we change the PM?
Well, again, I really think you need to evaluate it. I can tell you that some of the RCAs that we have, since I'm in charge of PMs, I look at it and it's, is this really going to happen again? Is it really something we need a PM for? Can it just be covered by your daily walkthrough? Somebody's walking by, and if this happens again, how are we going to know? Are the operators going to know? We have building management systems, with a lot of alerts and stuff, and people have screens. Maybe you have that. Maybe something will show up on the HMI. Maybe there's other indications you use predictive maintenance and tools, like IR scanning, motor circuit analysis, all those things. You really have to, I think, look at the big picture. Are we adding value by adding this task rather than just doing a check in a box and then telling a manager, oh yeah, it's not going to happen again because I changed my PM. I don't like doing those types of things. I really want it to be something that's more sustainable and just logical and is going to really help with the prevention of it over time.
And the next 2 questions kind of tie into each other. The first one is, what are some of the blockers preventing an effective RCA program?
Yeah, I put a lot of those on some of the slides there. I mean, first it's management commitment that we're going to do them. And it's identifying, based on triggers and whatnot, company policy and who should do them. Now, one thing in my company we're looking at, and we're still kind of developing this, is, we have a lady who's in charge of change management. And she has a very strong background in incidents and problems. And she kind of educated me that there's a difference, And the third tier then is event, root cause events. And so, we're looking at, we have documented a lot of problems, and we're going to use a little block in there to trigger. Okay, then once we get the software, I click that box means that there's to be an RCA, and then somebody needs to, in management, say, yep, okay, that is worthy of one. It's worthy of this level. You got to start there, and of course, you got to have the training. Get the right people who are engaged, who want to be part of it. And it's got to be cross-functional. You got to do all those elements, to make it effective.
And the next one, actually ask you, what is your biggest barrier that you've encountered when you've tried to develop RCA programs?
Yeah, well, the biggest one, I developed a program. I was only in the company about 3 months. My boss says, hey, we need a RCA program. My procedure is 20 pages long. I got a 5-page policy. I went to our headquarters in Sacramento. I had 20 people in there, did all the training. Like I said, we went by a year without doing it. Very, very frustrating. And so finally I went to the VP. I'm like, why do we even have a program? Are we ever going to do these? And a couple months later, there were 2 of them he gave to me, and I did them personally, rather than getting somebody else to do them. One was that shutting that breaker or opening that breaker we shouldn't have for the UDP and whatnot. And it was going to be shared with the customer. It was going to be shared with CEO. I went through the whole 9 yards, with using the software. And I thought, well, this should show the value of doing this. And maybe it did. I never got any feedback on it, which was frustrating. And I honestly don't know if all the actions got taken care of, but if you don't have the directors and managers and somebody following up on it and agreeing with you that this is action we should take, because you're probably not going to be the one doing the work, more likely, unless it's a specific reliability thing that affects your job and your job duties, it's somebody else. So it makes it a little bit nebulous, and who's in charge and who's going to make the action happen. So that's, I think, the frustrating part. Once you solve that problem, you'll have a pretty effective program.
And I believe that's all the time we have for questions. Thank you, everyone, for your participation today. Again, Lee, thanks for yet another amazing presentation. We always appreciate your time.